Running multi-conductor power limited tray cable, or PLTC, above the ceiling is appropriate for this application. Intrinsically safe systems must be installed in accordance with Article 504. PLTC cables are permitted for use in Class 1, Division 1 locations. Intrinsically safe circuits must be installed in accordance with the appropriate sections of Article 504. Since the control wiring is intrinsically safe and is being installed in a Class 1, Division 1 location, it must comply with Article 504. Section 504.30 states that the installation must be in accordance with the appropriate sections of Article 504. A seal is needed because the control wiring is entering an unclassified location from a Class 1, Division 1 location. The seal should be installed at the point of entry to maintain the integrity of the intrinsically safe system. Some additional considerations include the following. Firstly, use a certified intrinsically safe PLTC cable that meets the requirements of ANSI/Underwriters Laboratories 913. Secondly, ensure that the cable is properly supported above the ceiling and protected from damage. Thirdly, if the cable passes through any metal conduits, install a ground jumper between the conduit and the equipment grounding conductor inside the enclosure. Fourthly, mark the cable as intrinsically safe at the point of entry to the unclassified location. By following these guidelines, the intrinsically safe control wiring can be installed safely and in compliance with the National Electrical Code, or NEC. When working with intrinsically safe systems and hazardous locations, understanding the relevant code requirements is essential. Article 504 of the NEC provides specific guidelines for intrinsically safe systems. Section 504.20 emphasizes that intrinsically safe systems must be installed in accordance with Article 504. This means adhering to all the provisions and requirements outlined in this article to ensure the safety and integrity of the system. Section 336.10, paragraph 7, permits the use of PLTC cables in Class 1, Division 1 locations. This allowance makes PLTC cable a suitable choice for control wiring in hazardous environments. Section 504.30 stipulates that intrinsically safe circuits must be installed in accordance with the appropriate sections of Article 504. This reinforces the need to follow the specific guidelines within Article 504 that pertain to intrinsically safe circuits. When installing control wiring in a Class 1, Division 1 location, the wiring must comply with Article 504. This includes considerations for wiring methods, equipment, and installation practices to minimize the risk of ignition. Because the control wiring is transitioning from a Class 1, Division 1 location to an unclassified location, a seal is required. This seal prevents the migration of flammable gases or vapors from the hazardous location into the non-hazardous location, maintaining the integrity of the intrinsically safe system. The seal should be installed at the point where the wiring enters the unclassified location. This ensures that any potential explosion or fire is contained within the hazardous location. To ensure compliance and safety, it is crucial to use a certified intrinsically safe PLTC cable that meets the requirements of ANSI/Underwriters Laboratories 913. This standard specifies the requirements for intrinsically safe apparatus and associated apparatus. It ensures that the equipment is designed and tested to prevent ignition in hazardous locations. The cable should be properly supported above the ceiling to prevent strain and damage. Proper support also ensures that the cable remains in its intended location and does not pose a hazard. The cable should be protected from physical damage to maintain its integrity. Protection methods may include using conduit, cable trays, or other appropriate means to shield the cable from impact, abrasion, or other potential hazards. If the cable passes through any metal conduits, it is important to install a ground jumper between the conduit and the equipment grounding conductor inside the enclosure. This ensures that the conduit is properly grounded and that any fault current is safely conducted back to the source. The cable should be clearly marked as intrinsically safe at the point where it enters the unclassified location. This helps to identify the wiring as part of an intrinsically safe system and prevents accidental modification or disconnection. Following these guidelines helps ensure that the intrinsically safe control wiring is installed safely and in compliance with the NEC. Proper installation and maintenance are essential for the continued safe operation of intrinsically safe systems in hazardous locations. Consider the specific requirements of the application and the environment. Factors such as temperature, humidity, and the presence of corrosive substances can affect the performance and safety of the wiring and equipment. Ensure that all equipment used in the intrinsically safe system is properly rated for the hazardous location. This includes control panels, barriers, and other associated devices. Install and maintain the intrinsically safe system in accordance with the manufacturer's instructions. This helps to ensure that the system operates as intended and that any potential problems are addressed promptly. Regularly inspect the intrinsically safe system for any signs of damage or deterioration. This includes checking the wiring, seals, and other components for wear, corrosion, or other issues. Test the intrinsically safe system periodically to ensure that it is functioning properly. This may include testing the continuity of the wiring, the operation of the barriers, and the overall performance of the system. If any problems are found, they should be addressed immediately to prevent a potential hazard. Ensure that all personnel working on or around the intrinsically safe system are properly trained. This includes understanding the principles of intrinsic safety, the requirements of the NEC, and the proper procedures for installation, maintenance, and troubleshooting. Keep accurate records of the installation, maintenance, and testing of the intrinsically safe system. This helps to track the performance of the system and to identify any potential problems. When making any modifications or repairs to the intrinsically safe system, use only approved components and follow the manufacturer's instructions. This helps to ensure that the system continues to operate safely and in compliance with the NEC. Intrinsic safety is a protection technique for electrical equipment used in hazardous locations. It is based on the principle of limiting the energy available in electrical circuits to a level that is below the minimum ignition energy required to ignite a flammable atmosphere. Intrinsically safe equipment is designed to operate safely in hazardous locations without the need for explosion-proof enclosures or other protection methods. Intrinsically safe systems typically consist of an intrinsically safe apparatus, an associated apparatus, and an intrinsically safe interconnection. The intrinsically safe apparatus is the equipment that is located in the hazardous location, such as a sensor, switch, or actuator. The associated apparatus is the equipment that is located in the safe area, such as a power supply, control panel, or signal conditioner. The intrinsically safe interconnection is the wiring that connects the intrinsically safe apparatus to the associated apparatus. The associated apparatus limits the voltage and current that can be supplied to the intrinsically safe apparatus. The intrinsically safe interconnection is designed to prevent the propagation of energy from the safe area to the hazardous location. The intrinsically safe apparatus is designed to operate safely in the hazardous location, even if there is a fault in the system. Intrinsic safety is a widely used protection technique for electrical equipment in hazardous locations. It is a cost-effective and reliable method of preventing explosions and fires. By following the guidelines and recommendations outlined above, the intrinsically safe control wiring can be installed safely and in compliance with the NEC. This helps to ensure the safety of personnel and equipment in hazardous locations. Remember to always consult with a qualified electrical engineer or inspector when working with intrinsically safe systems. They can provide guidance on the specific requirements for the application and ensure that the installation is in compliance with all applicable codes and standards. Understanding the principles of intrinsic safety and the requirements of the NEC is essential for anyone working with electrical equipment in hazardous locations. By following the proper procedures and using approved equipment, the risk of explosions and fires can be significantly reduced. The National Fire Protection Association, or NFPA, publishes the National Electrical Code, which provides comprehensive guidelines for electrical installations in various locations, including hazardous locations. Article 500 of the NEC defines hazardous locations and classifies them based on the type of flammable substances present and the likelihood of their presence. Class 1 locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 locations are those where ignitable concentrations of flammable gases, vapors, or liquids can exist all the time or some of the time under normal operating conditions. Class 2 locations are those where combustible dust is or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 3 locations are those where easily ignitable fibers or flies are present but not likely to be suspended in the air in quantities sufficient to produce ignitable mixtures. Within each class, there are also divisions that further classify the degree of hazard. Division 1 locations are those where the hazard is present under normal operating conditions, while Division 2 locations are those where the hazard is present only under abnormal conditions, such as equipment failure or accidental release. The NEC provides specific requirements for electrical equipment and wiring in hazardous locations. These requirements are designed to minimize the risk of ignition and explosion. One of the key requirements is the use of equipment that is specifically designed and approved for use in hazardous locations. This equipment is typically marked with a label indicating the class, division, and group for which it is approved. Another important requirement is the use of wiring methods that are suitable for hazardous locations. These wiring methods are designed to prevent the escape of flammable gases or vapors and to minimize the risk of ignition. The NEC also provides requirements for grounding and bonding in hazardous locations. These requirements are designed to prevent the accumulation of static electricity and to ensure that any fault current is safely conducted back to the source. In addition to the NEC, there are other standards and regulations that may apply to electrical installations in hazardous locations. These include standards from organizations such as Underwriters Laboratories, the International Electrotechnical Commission, and the Occupational Safety and Health Administration. It is important to be familiar with all applicable codes and standards when working with electrical equipment in hazardous locations. This helps to ensure that the installation is safe and compliant with all regulations. Proper training is essential for anyone working with electrical equipment in hazardous locations. This training should cover the principles of hazardous location safety, the requirements of the NEC, and the proper procedures for installation, maintenance, and troubleshooting. By following the proper procedures and using approved equipment, the risk of explosions and fires can be significantly reduced in hazardous locations. This helps to protect personnel and equipment from harm. Remember to always consult with a qualified electrical engineer or inspector when working with electrical equipment in hazardous locations. They can provide guidance on the specific requirements for the application and ensure that the installation is in compliance with all applicable codes and standards. Intrinsically safe systems are just one of several methods used to protect electrical equipment in hazardous locations. Other methods include explosion-proof enclosures, purged and pressurized enclosures, and non-incentive equipment. Each of these methods has its own advantages and disadvantages, and the best method for a particular application will depend on the specific circumstances. Explosion-proof enclosures are designed to contain any explosion that may occur inside the enclosure. They are typically made of heavy-duty materials and are designed to withstand the pressure of an internal explosion. Purged and pressurized enclosures are designed to prevent the entry of flammable gases or vapors into the enclosure. They are typically purged with a clean, dry gas such as nitrogen or air, and are pressurized to a level that is slightly above the surrounding atmosphere. Non-incentive equipment is designed to not produce sparks or hot surfaces that could ignite a flammable atmosphere. It is typically used in Class 1, Division 2 locations where the hazard is present only under abnormal conditions. When selecting a protection method for electrical equipment in a hazardous location, it is important to consider the specific requirements of the application, the cost of the equipment, and the level of protection required. A qualified electrical engineer or inspector can provide guidance on the selection of the appropriate protection method. In addition to selecting the appropriate protection method, it is also important to ensure that the equipment is properly installed and maintained. This includes following the manufacturer's instructions, using approved wiring methods, and performing regular inspections and tests. Proper installation and maintenance are essential for the continued safe operation of electrical equipment in hazardous locations. By following the proper procedures and using approved equipment, the risk of explosions and fires can be significantly reduced. This helps to protect personnel and equipment from harm. Remember to always consult with a qualified electrical engineer or inspector when working with electrical equipment in hazardous locations. They can provide guidance on the specific requirements for the application and ensure that the installation is in compliance with all applicable codes and standards. The application involves replacing a mixer that has an across-the-line starter with a new unit that has a variable frequency drive, or VFD, to run the motor. The power wiring is existing. The VFD will control the speed of the motor, and the intrinsically safe control wiring will be used to start, stop, and adjust the speed of the motor. The speed potentiometer allows the operator to adjust the speed of the mixer from the operator station. The intrinsically safe design ensures that the control signals do not introduce any ignition risk into the hazardous location. This approach enhances safety and provides better control over the mixing process. Ensure that the VFD is also rated for the environment in which it is installed. Depending on the location, the VFD may need to be installed in an enclosure that is rated for the specific hazardous environment. Proper grounding and bonding of the VFD and associated equipment are crucial for safety. Follow the manufacturer's instructions and the requirements of the NEC for grounding and bonding. The VFD should be properly sized for the motor to ensure efficient and reliable operation. Consult the motor manufacturer's specifications and the VFD manufacturer's guidelines for proper sizing. Consider the harmonic distortion that can be produced by VFD. Harmonic filters may be required to mitigate the effects of harmonic distortion on the power system. This is particularly important in facilities with sensitive electronic equipment. Regularly inspect and maintain the VFD to ensure its continued safe and reliable operation. This includes checking the cooling system, connections, and other components for wear or damage. The use of a VFD offers several advantages over an across-the-line starter, including improved motor control, energy savings, and reduced mechanical stress on the motor and driven equipment. The VFD allow for precise speed control, which can optimize the mixing process and reduce energy consumption. The VFD can also reduce the starting current of the motor, which can help to prevent voltage dips and reduce stress in the power system. The reduced mechanical stress in the motor and driven equipment can extend the life of the equipment and reduce maintenance costs. However, VFD also have some disadvantages, including higher initial cost, the potential for harmonic distortion, and the need for specialized knowledge and training for installation, maintenance, and troubleshooting. When considering the use of a VFD, it is important to weigh the advantages and disadvantages carefully and to ensure that the VFD is properly selected, installed, and maintained. Consulting with a qualified electrical engineer or technician can help to ensure that the VFD is properly integrated into the system and that all safety requirements are met. The use of intrinsically safe control wiring and a VFD provides a safe and efficient solution for controlling the mixer motor in a Class 1, Division 1 hazardous location. By following the guidelines and recommendations outlined above, the installation can be completed safely and in compliance with all applicable codes and standards. Remember to always prioritize safety and to consult with qualified professionals when working with electrical equipment in hazardous locations. The selection of appropriate wiring methods is crucial for ensuring the safety and reliability of electrical systems, especially in hazardous locations. Power limited tray cable, or PLTC, is a type of cable that is specifically designed for use in control and instrumentation circuits. PLTC cable is constructed with a flame retardant jacket and is listed for use in cable trays, which provides mechanical protection and support for the cable. PLTC cable is also typically smaller in size and more flexible than other types of cable, which makes it easier to install in tight spaces. In addition to PLTC cable, there are other wiring methods that may be suitable for use in intrinsically safe control circuits, depending on the specific application and the requirements of the NEC. Some of these wiring methods include shielded cable, twisted pair cable, and fiber optic cable. Shielded cable is used to protect the signal from electromagnetic interference or EMI, which can cause errors in the control circuit. Twisted pair cable is used to reduce the effects of noise and crosstalk in the control circuit. Fiber optic cable is used to transmit signals over long distances without degradation or interference. When selecting a wiring method for an intrinsically safe control circuit, it is important to consider the following factors. Firstly, the distance between the intrinsically safe apparatus and the associated apparatus. Secondly, the level of noise and EMI in the environment. Thirdly, the requirements of the NEC. Fourthly, the cost of the wiring method. The NEC provides specific requirements for wiring methods in hazardous locations. These requirements are designed to minimize the risk of ignition and explosion. It is important to be familiar with these requirements when selecting a wiring method for an intrinsically safe control circuit. In addition to the NEC, there are other standards and regulations that may apply to wiring methods in hazardous locations. These include standards from organizations such as Underwriters Laboratories, the International Electrotechnical Commission, and the Occupational Safety and Health Administration. It is important to be familiar with all applicable codes and standards when selecting a wiring method for an intrinsically safe control circuit. Proper installation of the wiring method is crucial for ensuring the safety and reliability of the intrinsically safe control circuit. This includes following the manufacturer's instructions, using approved fittings and connectors, and performing proper grounding and bonding. Regular inspection and maintenance of the wiring method are also important for ensuring its continued safe and reliable operation. This includes checking the cable for damage, verifying the integrity of the connections, and testing the grounding and bonding system. By following the proper procedures and using approved equipment, the risk of ignition and explosion can be significantly reduced in hazardous locations. This helps to protect personnel and equipment from harm. Remember to always consult with a qualified electrical engineer or inspector when working with electrical equipment in hazardous locations. They can provide guidance on the specific requirements for the application and ensure that the installation is in compliance with all applicable codes and standards.